Okay, I'm back. I'm still talking about electricity and mechanical and hydraulic metaphors. Uh, what's the difference between mechanical and hydraulic metaphors and metaphors of electricity? What I was saying is that electricity, I think, requires metaphors to understand it, whereas mechanical and hydraulic devices don't. The reason for that is, I think, that the body, at the level in which it interacts with the world, at the level of the sensorium, at the level of the fingertip, the taste bud, the eyeball, the eardrum, at that kind of level, it operates in the world of mechanics and hydraulics. So it has a kind of direct experience, direct in inverted commas. Whereas electricity is not something that we operate at. So we talk about electricity as if it was a liquid. We talk about currents and flows and valves. And I was talking about this experiment, wasn't I? Yeah, okay. So this experiment was done where people who weren't electronics experts were shown circuit diagrams, simple schematics with switches and buzzers and bells and that kind of thing on them. And some of these were circuits in series and some of these were circuits in parallel. Now, half of these subjects were primed to favour an electricity metaphor which understood electricity as the flow of a liquid. Everybody understands it as a flow, but these people have been understood it as the flow of a liquid. The other group had understood it as the flow of a particulate solid, as if it was like sand grains through an hourglass, or as if it was more likely even as if it was the flow of a crowd. So that's a steam train passing the bottom of the field. I can see its smoke. It's fantastic. Okay, so some have been primed to understand it as the flow of a liquid. Some understand it primed to understand it as the flow of a crowd or a particular solid. And then we're asked to make predictions about what would happen in these circuit diagrams if certain switches were shown. What you find apparently in that is for those people who are primed to think of electricity in liquid terms, they're very good at making predictions about circuits that are wired in series, but bad at making predictions about parallel circuits. Conversely, people who have been primed to think of electricity as a crowd or as particulate solids flowing through, in the way that sand through an hourglass flows, are very good at making predictions about what parallel circuits will do, but are not so good at predicting the behaviour of currents in series circuits. So there's something funny going on there. But the key point is that we're not accessing electricity in and of itself. We're accessing it through the medium of embodied metaphors. We have a completely concrete and embodied experience of what liquids do and what particulate solids do and what crowds do, because that is at the level of our sensorium. And so the only way we can understand electricity is by the application, completely unconsciously most of the time, of those kind of metaphors. And the small variations in those metaphors are revealing themselves in the details of that particular experiment. Okay. Yeah, fantastic stuff. I'm just seeing what notes I've made on your video there, mate. Bodies move with brute force, brains are electric. Yeah, bodies move with brute force. I just want to make sure I've got this, because I'm kind of rehearsing this for myself as much as for you. I hope you don't mind that. I think you're right. Bodies move with what you've referred to as brute force, which I'm understanding to mean basically in the Newtonian way, with under the power and the momentum of levers and pulleys and all those kind of things, and the other stuff to do with hydraulics that I mentioned in the first part of this video. And brains, I think you're absolutely right. Brains do work electrochemically, but our minds, I'm not sure, do. And I know there's a complexity there, but I would say that mind, at least the cognitive process that the brains do, this thing that we're doing right now, this I'm not. I think it's the mobilization of lots of metaphors and figurative kinds of processes of figuration, I should perhaps say. And those figurations come from somewhere, and I think they come from the movement of the body in space. I guess I'm following people like Rodolfo Linas here and Lakoff and Johnson and people like that. You know, the metaphors that make up our minds come from the activities of our bodies in space and the human sensorimotor system. And the human sensorimotor system operates at a particular scale, and that's the scale of the mechanical and the hydraulic. It's not the scale of the electrical or the quantum or the relativistic or any of those kind of things. It operates, you know, broadly speaking, newtonian. And there's quite a bit of work being done on sometimes called folk physics, the kind of intuitions that people have prior to, you know, gaining specific knowledge about a particular set of, you know, physics really. And folk physics is very similar to Newtonian physics. You know, people guess. When people make guesses about the way the world works, they tend to guess in a way which is broadly speaking Newtonian, because of our bodies tend to operate at that scale. The other thing about the brain, which I think is interesting, this is something David Hubel says. I don't know how you pronounce his surname. It looks like Hubel. He's talking about bodies and brains, and I think he's slightly wrong. I've made a couple of videos about this, but he says the mind is like a printing press. I think he says, and sooner or later we'll find out how it works in exactly the same way that you are, and we understand the mind in the same way that we understand the printing press, or we'll come to understand. No, sorry. Let me just rephrase that. Back it up. He says the brain is a mechanical machine. It's a machine. The brain is a machine, and one day we will understand the brain in the same way that we understand the printing press. That's what he says, something like that. And I think he's wrong, basically, because we'll understand the brain, you know, through some of the exercises in that kind of electrochemical theorization that you kind of pointed at. But we won't understand it in the same way that we understand the printing press. When we understand the printing press, I think we're relating it to our bodies. We're operating at a sensorimotor level, which is, you know, broadly speaking, Newtonian. It's levers and presses and pulleys. The brain isn't like that, I don't think. It's something different, so we have to use different mechanisms to understand it, and I think those are the mechanisms of metaphor. I think we'll understand our mind in the same way we understand the printing press, but that's perhaps a different story. Well, I feel like I've wobbled on a long time there and not really got to a conclusion. Basically, I'm thanking you for that thoughtful video there, apropos, and do please give my kind regards to Tom Darby. I must buy his book, it sounds great. Yeah, just to sum up, I would agree that mechanical and hydraulic metaphors from 16th right to the end of 19th century were incredibly rich, were and continue to be and have always been a rich source of understanding. I think the development of those technologies aided our understanding. They became tools for thought as well as tools for action in the world. Once you get to electricity, and particularly the technologies of the screen, as I kind of pointed out in my previous video, I think you are in a different realm. I'm not sure we can use the technologies of the circuit and the screen directly. I think we can only access that via the technology of the mechanical machine and the hydraulic device, I think. Anyway, thanks very much.